Welcome to the Deep Dive. Today, we're exploring a really extraordinary idea, something that might just shift how you view, well, almost everything. What if the answers to huge global challenges, things like poverty, aren't just buried in economics or policy debates? What if they actually connect back to the most fundamental laws of physics? Our mission today is to take a deep dive into Dr. Nimrod Israeli's Universal Law of Increasing Complexity, or ULSC for short. This law suggests that prosperity, resilience, even how the universe itself evolved, might all spring from the exact same core principles. It's a big claim, connecting, something as simple as fruit fly trap all the way to the Big Bang itself.
And it's important to stress this isn't just some abstract academic thought experiment, right? If this law truly holds universally, Dr. Israeli suggests it offers what he calls a practical blueprint for transformation. Think about that. Designing systems, maybe communities, businesses, even how we think about the cosmos, designing them to be inherently more capable, more aligned with, well, long-term flourishing. It implies we could gain a huge amount of agency.
Okay, and here's where it gets really compelling for me. This proposed law, ULIC, it directly takes on one of the biggest, longest-standing mysteries in all of science. We're talking about the century-old conflict between quantum mechanics and general relativity. What if, and this is the radical idea, what if their disagreement isn't actually a problem we need to solve? What if it's the very engine of progress, maybe the friction that sparks something new?
Exactly. It flips the script on how we often think about scientific unification.
So let's start at the beginning then. Dr. Israeli's starting point seems quite profound. He has this observation: dig deep into any problem, and eventually you will reach physics, mathematics, and philosophy. And he's grappling with a really fundamental human question. Why do some communities thrive while others seem stuck in cycles of poverty? He argues that just throwing money at it, charity and these fragmented efforts, they often miss the mark because they don't get at the underlying universal laws that actually govern how things emerge, how capabilities arise.
Right. And that deep dive, that inquiry, led him straight to formulating this universal law of increasing complexity. The core idea is surprisingly, maybe deceptively simple. It says that these emergent capabilities we want, like prosperity or resilience in nature, or even just basic survival, they arise from a very precise alignment. An alignment of three essential forces: energy, structure, and direction. It's quite an elegant framework when you think about it, especially given how ambitious it is.
Elegant, yes. But I can imagine some listeners thinking, okay, reducing complex social issues, human societies, down to physics. Doesn't that feel a bit, I don't know, deterministic? Or maybe even reductionist? Where does human choice fit into these universal laws?
That's a really important question. And it's not about determinism in the sense of preordained outcomes. Think of it more like understanding the principles that either enable or inhibit emergence. So if you grasp the laws of aerodynamics, you can design an airplane, right? But you still need pilots, engineers, conscious decisions to build and fly it. ULIC is similar. It offers a framework for how capability emerges, but we still need to provide the specific conscious direction within that framework. What makes it truly remarkable, though, is Dr. Israeli's insistence that this law applies across all scales. He gives examples from, like you said, a simple fruit fly trap, how that works, all the way up to a functioning village, a nation, and yes, even the universe itself.
That is a genuinely sweeping claim. A fruit fly trap and the entire cosmos operating on the same fundamental law. What's the most maybe surprising common thread he found across these incredibly different systems that convinced him it was universal?
Well, he noticed that in any system that's thriving, that's really functioning well, whether it's biological, social, whatever, you consistently see these three elements working together: energy, structure, direction. Take his fruit fly trap example. It harnesses energy, right? The fly's own metabolic energy, its drive to find food. It uses structure, the shape of the bottle, the lure inside, the funnel. And it imposes direction, that one-way path that leads the fly in but makes it hard to get out. The surprise isn't just that those three things are present, it's that their precise alignment, how they interact, is what defines the system's capability in this case, trapping the fly. And crucially, it's not just about things getting more complex randomly. He sees it as a directional process. Systems that manage to hold internal contradictions, internal tensions, they don't just stagnate or break, they evolve. They develop new abilities, expand what they can do.
So it's not just piling things up. It's more like a purposeful unfolding, guided by these principles.
Precisely. Purposeful might be a strong word, but definitely directional. Think about human flight. For literally millions of years, 2.5 million perhaps, no hominid flew. We were completely earthbound. But then we uncovered the laws of flight aerodynamics, lift, thrust, all that. And once we understood those principles, eventually even children could soar through the skies in airplanes. Dr. Israeli's belief is that tackling huge challenges like hunger, poverty, maybe even ecological collapse will follow a similar path. It's by uncovering these fundamental universal laws governing emergence that we gain the real agency, the tools to design solutions that actually genuinely work.
Mm.
So we're not just, projecting our human wishes onto the cosmos. We're asking, does the cosmos itself run on principles we can learn from and apply?
Okay, so if ULIC is truly universal, as the claim goes, it needs to hold up under the toughest scrutiny. Which brings us, as you said, to the ultimate test case. That fundamental clash between the two pillars of modern physics, quantum mechanics and general relativity. This is where ULIC offers, well, a really different perspective.
Yeah, let's just quickly recap for everyone. On one side, you have quantum mechanics, QM. This theory governs the world of the incredibly small particles, atoms, fields. It's a realm of probabilities, fluctuations, constant change, where particles can be in multiple places at once, where certainty dissolves into likelihoods. Even empty space, according to QM, is buzzing with energy.
Right, the fuzzy probabilistic microworld. And then on the other side, you have Einstein's general relativity, GR, which paints this grand sweeping picture of the massive and the vast. Gravity isn't a force pulling things, it's the curvature of space-time itself, shaped by mass and energy. GR explains planets orbiting stars, black holes, the expansion of the whole universe. It's incredibly elegant on the cosmic scale.
And both theories are just astonishingly accurate. I mean, unbelievably successful within their own domains. They've been tested rigorously, time and time again. But they just don't agree. They fundamentally clash. The problem becomes really acute when you look at extreme situations like the very beginning of the universe, the Big Bang, or deep inside a black hole. Situations where you have both immense gravity, GR's domain, and tiny scales where quantum effects, QM's domain, are crucial. And under those conditions, the maths it breaks down. The theories give nonsensical answers like infinities. The core issue, sort of simplifying it, is QM assumes this background stage of space and time that's fixed, smooth, continuous. But GR says, no, space and time are the actors. They are dynamic, they get warped and curved by matter and energy. One is fundamentally discrete and probabilistic, the other is continuous and geometric. Their basic languages are incompatible.
And this incompatibility, this deep conflict, has fueled this massive scientific quest for decades, right? The search for a theory of everything. People have proposed incredibly complex ideas like string theory or loop quantum gravity, trying to bridge that gap. But so far, none of them has really delivered that knockout punch, the conclusive experimental proof, or gained universal acceptance.
Exactly. So what we're left with isn't really a lack of knowledge in either QM or GR. They both work brilliantly on their own turf.
Hmm.
Instead, it's what Dr. Israeli calls a fracture in coherence. It's like having two perfect, incredibly detailed maps of different regions that just don't line up at the border. We have these two super powerful, verified theories, but there's no shared foundation connecting them. A fundamental split right at the heart of our understanding of reality.
Okay, so if that's the problem physics has been wrestling with, how does ULIC come in? This is where it gets really interesting, because ULIC suggests maybe this contradiction isn't a bug, it's a feature. Maybe it's a structured tension that's actually necessary for something greater to emerge. As if the universe didn't start in perfect harmony, but maybe in a state of productive conflict. And that friction is what drives complexity.
That is precisely the game-changing insight ULIC offers here. Let's map it onto those three core elements: energy, structure, and direction. First, energy. You could say quantum mechanics almost perfectly embodies this constant inflow of energy, potential, fluctuation. The quantum vacuum itself is seething with possibilities, probabilities, this dynamic potential energy. It keeps the system from ever being static, always full of possibility.
Okay, so QM represents the energetic, dynamic potential. What about structure then?
That's where general relativity comes in. GR provides the essential structure, the framework. It describes the geometry of space-time. It brings continuity, coherence, predictability across vast scales. Without that structure, that sort of large-scale order, the boundless energy described by QM would just be, well, chaos. It wouldn't have any form or endurance. So relativity gives shape and persistence to the cosmos, allowing complex systems the time and stability they need to arise.
All right, energy from QM, structure from GR, that leaves direction. This always feels like the trickiest part. Where does the direction come from in this cosmic picture?
Well, this is really fascinating. UIC suggests direction can come from multiple places. It could be seeded by the initial conditions of the universe, the arrow of time itself, the flow towards increasing entropy, or And this is key. Dr. Israeli proposes a specific concept he calls Ginordo. Think of it as this fundamental drive or pressure within systems towards continuous, sometimes unpredictable transformation and increasing complexity. But perhaps most intriguingly for the specific conflict, the direction might also arise directly from the ongoing tension between QM and GR themselves. That incompatibility, that fracture in coherence, creates this sort of internal pressure, not just for scientists scratching their heads, but maybe within the universe's own operating system, you could say. It's the friction itself, when held within the structure provided by GR, that pushes things, that guides evolution towards novelty.
Wow. Okay, so if we accept that premise for a moment, this interplay of quantum energy, relativistic structure, and tension-driven direction, what's the result? What do we actually see?
Well, we see the history of the universe. We can observe this incredible unfolding, this continuous sequence of emergent complexity. You start with fundamental particles and forces right after the Big Bang. From that, somehow, stable atoms emerge. That's a huge jump in complexity. Then atoms combine to form molecules. Chemistry. That opens up a whole new realm of possibility. Chemistry eventually gives rise to complex biological systems, which leads to life. And life evolved towards awareness, consciousness, and eventually things like culture, art, science itself. It's this unbroken chain of emergence.
And each step builds on the last, creating something genuinely new.
Exactly. At each transition, totally new capabilities pop into existence. Capabilities you absolutely couldn't have predicted just by looking at the previous level. It's not just layers stacked on top of each other. Dr. Israeli describes it as a nested system. Everything is interconnected. Each new layer builds upon, interacts with, and even reshapes the layers that came before it. And us, Homo sapiens, we're not separate from this. We're embedded within this grand pattern. We're part of this process, able to actually reflect on it, study the very laws that produced us.
So pulling it all together then from the ULIC perspective, that century-old contradiction between QM and GR isn't some roadblock we need to bulldoze. It's actually part of the universe's generative structure. Is that the idea?
That's the core takeaway. The beauty of looking at it through the ULIC lens is that it suggests growth and evolution don't require perfect harmony. In fact, it might depend on tension, on contradictions, but crucially, it has to be tension that is held, contained, guided, stabilized by structure. Held just long enough for something genuinely new and more complex to emerge from that friction. So the task for science, maybe, isn't just to force these two theories into a single unified box immediately. Perhaps it's also about building a conceptual framework, like ULIC aims to be, that allows this productive tension to exist, to be understood, and to keep driving our understanding forward.
That really reframes the whole quest for unification. So what stands out most to you from this whole exploration? For me, it's that really profound idea, maybe counterintuitive, that progress, whether it's in fundamental physics or maybe even in society, doesn't always come from smoothing out differences or erasing contradictions. Sometimes it comes from finding ways to hold those contradictions within a larger structure, creating the space for something entirely new to emerge from the interplay.
I agree. And if this universal law, or something like it, holds true, it really encourages us, I think, to think critically about how we approach problems everywhere. Not just in science labs, but in our daily lives, too. Are we always defaulting to trying to eliminate disagreement, smooth over conflict immediately? Or could we sometimes learn to harness that productive tension, to use it carefully within our teams, our communities, our organizations, to actually foster genuine emergence, to find new capabilities we didn't even know were possible?
That's a powerful thought to end on. So maybe something for you, the listener, to reflect on as you go about your day. What contradictions, what tensions are you bumping up against right now? Maybe at work, maybe in your community, maybe even just within yourself. And instead of trying to force them into some kind of easy harmony, could you think about building a framework around them? Could you hold that tension in a way that might allow a completely unexpected solution or a deeper understanding to emerge? Think about that.